Hey, Mr. Jorgens here. Welcome to Math. We're doing section 3.1 on functions today. It's going to be all about linear functions. It's part one, just kind of like an introduction to functions. And so make sure you're paying attention. There will be a few questions along the way. Glad you guys are here. All right, we're starting off chapter 3, and it's a little different than some of the equations and inequalities stuff. It's a lot less procedural and a lot more conceptual. So throughout the chapter, we're going to have a little bit more definitions. And we're going to start there for this one. So we have two kind of key terms that we need to know. The first one is a relation, and a relation pairs inputs, which we're going to call the inputs our x variable with outputs y. So a relation pairs inputs x with outputs y. And a lot of times in math, you're going to see what's called a coordinate point, like for instance 2, 5. And what a coordinate point really is it's pairing an x with a y. So it's an example of a relation, right? And in a point, we always have an x and a y. So a coordinate point is one way of identifying a relation between an x and a y. And this chapter is going to be all about relations between x and y. Now, specifically today, we're going to be questioning whether something is a function or not. So whether a relation is a function. And a relation is a function if each input x has exactly one output y. And that's going to help us answer our question for today. Our big question is it a function? And on the next few screens, that's going to be our question for pretty much every problem in this section is it a function? And the way we're going to know the answer to that question is if each input x has exactly one output y. There's a few different ways that we're going to be able to show or display functions in math class right now. And the first one is something called set mapping. And the way set mapping is going to work is we're going to relate a set of x's to a set of y's. How that's going to work is we're going to be given a list of inputs and outputs. So let's say, for instance, the inputs are -1, 3, and 11, and the outputs are 4 and 15. So one possible set mapping or one possible relation between x and y would be that if you input -1, it's going to output 4. And the way we can show that is by drawing an arrow to show that an input of -1 is going to output 4. An input of 3 could then output 15, and an input of 11 could also output 15. Now, our rule or our question is it a function? That's our big question for today. And so this is a relation. It relates -1 in x to 4 in y, 3 in x to 15 in y, and 11 in x to 15 in y. And if you remember back to our kind of main idea here, it's going to be a function if each x goes to exactly 1 y. And you can see that each x goes to exactly 1 y, right? -1 goes to 1 y. x3 goes to 1 y 15, and x11 goes to 1 y 15. So it is a function because each x goes to 1 y. Now, I'm going to show you an alternate set mapping where this time it won't be a function. So let's say we have a set of x's going to a set of y's. And this time, let's say our set of x's is 1 and 2, and our set of y's is -2, 0, and 4. And let's say for our set mapping, 1 is going to map to -2, 2 is going to map to 0, and 2 is going to map to 4. If you notice on the first one, right here, we had two different x's going to the same y. That's okay, because each x has to have one y. But over here, this guy right here is not okay, because I have one x going to two different y's, right? And that's a problem because I have this x is going to this y, that's good. I have this x going to this y, which is fine, but I also have that same x going to a second y value, which is not okay. So in terms of answering the question, is it a function? This second one would not be a function because by definition, each x has to go to one y. So I can't have one x going to two different y's, which is what I had here. Over here, I had two different x's going to the same y. That's fine. It's still a function. Over here, that's not okay. All right, you go ahead and try one of the set mapping questions right now. The question is it a function? Go ahead and enter your answer when you're ready. So on this one, our answer would be yes, it is a function, right? Because I have each individual x mapping to one y. You can see each of the four x's, which I underlined in a different color, each go to exactly one y. I do have two different x's going to the same y, which is fine, but I don't have any one of my four x's going to two different y values, which would be a problem there. So this one, yes, it is a function. All right, let's look at a second type of display here, a second type of way we can look at functions, and this is by looking at the points. And in this one, we're going to have to do an extra step to set up the set mapping in order to answer the question of is it a function. So is it a function? We know that a function means each x goes to one unique y. Now in each one of these points here, it's an x comma y, right? So what I'm going to do is I'm going to set up my set mapping here. Now what this first point is saying is that an x goes to 0 in the y, right? So if my x value is 4, it's going to go to 0. It's going to map to 0 in the y. So if I input x equals 4, it's going to output 0 as the y. Now my second point here of 8 with 7 as the y is going to indicate if I input an x of 7, it's going to if I input an x of 8, it's going to output a 7 of y. 6 comma 4 is going to mean that if we input a 6, it's going to output a 4. 4 comma 3 means if I input a 4, it's going to output a 3. Now I should notice that this is x and y here, and I already have an x of 4. So I don't need to relist x as 4 again since I already have it in the input set. But I am going to have to add 3 to the output set, and I'm going to map my 4 to 3 there. And then I have an input of 5, which is going to map to an output of 2. Now I should see a red flag here, and my red flag should be this value right there. My 4, one x value is outputting to both 0 and 2. And that's a big no-no, right? I can't have one x value outputting to two different y values. So because of that, this is not a function, right? Because each x value has to output to one exact y value if it's going to be a function. So if you're given a list of points, you're going to first set up the set mapping and then see if each x maps to exactly one y. All right, here's one for you to try. Is it a function? There's a list of 4 points there. Start by drawing that set mapping and then determine whether there's an x value that's going to map to two different y values or not. All right, let's take a look at this one. Our first value, -5, is going to map to 0. So -5 as an x is going to map to 0 as a y. Then 1 comma 0 is the second point, so 1 as the x is going to map to 0 as the y, and that's okay, right? I'm allowed to have two different x values both mapping to the same y value. I just can't have one x value mapping to two different y values. Then I have 5 comma 0 as my third point here. So 5 in the x is going to output as 0 as the y, and that's still okay, right? Because each of my three x values just has one y value as the output. Where I'm going to run into a problem is on this fourth point here, 5 comma 10, because that's going to say that my 5 is also outputting to a 10. And this is my big issue right here, right? My 5 is mapping to both 0 and 10. That's a problem, right? The fact that -5 went to 0 and 1 went to 0 and 5 went to 0, that's okay. But my issue is right here that my 5 is mapping to two different y values. So because of that, this is not a function. All right, the third type of display we have to be ready to work with is a table. And so we can see I have a table set up here, and the question is it a function? So I'm going to always turn things into a set mapping to see if I have an x that's mapping to two different y's. So if I draw my set mapping here, I'm going to start with my first pair. So if you see, I want to see a pair, or a relation between an x and y. And that would be a relation between x and y, right? And the way that x and y are related in that case is that an input of -2 is going to lead to an output of 3. Then my next pair x and y would be -1 and 4, right? And that's going to say that an input of -1 is going to output to an output of 4. And so on, right? The next one's going to be 0 and 5. So 0 in the x is going to map to 5 in the y. And now this is going to be my red flag right here, because I also have another 0, right? 0 in the x, but this time it's mapping to 6 in the y, right? And that's going to be a red flag because I have this situation right here, right? That's bad. I have an x that's mapping to 2 different y's, so it's not going to be a function. I'll finish up my set mapping though with 1 going to 7 and 2 going to 8. There's no real problem there. But because of this guy right here, I'm going to say it's not a function because I have an x value that's mapping to 2 different y values. All right, here's one last one for you to try. I've got a table of values set up. You're going to need to convert it to a set mapping and then answer the question, is it a function, right? Does each x map to one exact y? Hopefully you can see on this one that yes, it is a function because each x goes to exactly one y. I have my blue relation 2 going to 5, my green relation 4 going to 9, and my 6 relation of 6 going to 11. Each x goes to one y. It is a function. This was part 1 of section 3.1. Come back tomorrow for part 2.